All right, we're going to finish the notes, but we're going to back up to the front page first and look at these statements here again. Because when we first talked about these, we hadn't talked about converse, inverse, contrapositive yet, and those truth values. So let's look back at, we'll start with C, because we decided, was C true or false? C is false, right? Because if there's ever one time it's false, it's false. Are there lots and lots of times when it could be true? Yes, but that's irrelevant if there's even one time. There could be a ton of times when it's false. It could be just one time when it's false. But if there's anything that it's false. All right, so then the converse would be, if you live in Texas, then you live in Pasadena. Is that true or false? That's false. That's a little bit more obvious false, right? Okay, so then this says, if an angle is obtuse, it has a measure of 100 degrees. True or false? False, right? The converse, if an angle has a measure of 100 degrees, then it is obtuse. True or false? True, because if it's 100 degrees, it's obtuse, okay? So this was an example of false, false. This is an example of false, true. And then this is, if I am in pre-AP geometry at PMHS, then Mrs. Finnan is my teacher. Is that true or false? That is true. Converse, if Mrs. Finnan is my teacher, then I'm in pre-AP geometry at PMHS. False, okay? Because I don't teach just pre-AP geometry, right? So this is true, false. This is false, true. This is false, false. If a butterfly has a curved back line on its hind wing, then it is a viceroy. That's true, okay? So then if a butterfly is a viceroy, then it has a curved black line on its hind wing. That's true. That would be a true, true. Okay, so there's lots of different combinations of what could happen there. Does that make sense? Okay, good. All right, so then back over here, we had the converse, inverse, contrapositive. Make sure we understand this notation and all that good kind of stuff, right? And then let's go back, and we were here. So I'm going to go back and add a few things to this. So our conditional is if P, then Q, right? So if two angles are supplementary, then they are a linear pair. We decided that was false. Had a very good example of why it was false. And I kept thinking all day, like, why have I never put that as the example before? Because usually the only thing I ever get is that to be a linear pair, they don't have to be adjacent. So we can draw two that aren't adjacent. And, but then as the day went on, I realized that I usually don't do this at this time of the year. Like usually when we do this lesson, because it's supposed to come earlier, or it can come early, we hadn't even talked about that yet. It's like, that's why I never thought to put that. So anyway, but that's a good one too. If two lines are parallel, then same side interior angles are supplementary. And this is an if-then statement. When we started this material, this is when I told you about these because we had skipped it, right? And so now that it's, because that way we can do if P then Q, that sort of thing. Okay, we good? All right. So then the converse is if Q then P, right? And then the inverse is when we negate the conditional. So if not P, then not Q. So we have if two angles are supplementary, then they are a linear pair. If two angles are a linear pair, then they are supplementary. And then if two angles are not supplementary, then they are not a linear pair. I think the first time I wrote it, I left out that word not. So then the contrapositive is when we do both. We switch them and make them negative. So if not Q, then not P. Right? We all good with all that? Okay. So in order to write that, it would be if what? If two angles, good, are not a linear pair, linear pair, then they are not supplementary. So you have to be very careful that when you are negating things that you use the word not. Sometimes just the word not by itself isn't enough, or it doesn't make sense in the English language. You might have to say does not or is not or something like that, but you don't change, if it doesn't sound right, you can't change what it's saying. So I couldn't say if two angles are not a linear pair, then they are vertical angles. Like that just totally changes what the whole statement is about, right? So we can't change the material in the statement. We just have to, if you change anything, it just has to be like little grammar things for English, and that's like it. All right, so is this true or false? True or false? So if they are not a linear pair, then they are not supplementary. Can they still be supplementary and not be a linear pair? Yes. Okay, so in order to find a false, if two angles are not a linear pair, then I have to make this be the opposite. If I can say then they are supplementary, then this doesn't work, right? So if two angles are not a linear pair, they can still be supplementary, right? Can we use the same example we did up there? Yes. If two lines are parallel, then, actually let's use a different pair of angles just because. Same side interior angles are supplementary. Instead of that, when we were using parallel lines, what's another set that would be supplementary? Same side exterior. Same side exterior angles are supplementary. Oops. We good? Any questions? All right. Now, I didn't put my false there. Did I really have to think real hard about the contrapositive and whether or not it was true or false? No, because I had already decided that. And remember, these are logically equivalent statements. That is super duper important for you to understand which ones are which, because the material of the sentence doesn't always matter when you're trying to answer some of these questions. I can give you questions about nuclear physics, and it doesn't matter if you don't even understand what it's talking about. You look at the structure of the sentence. So if the conditional is false, you are guaranteed that the contrapositive is going to be false. Could these two also be false? Is that possible? Not in this specific sentence, but I mean just any sentence I use. Could all four things be false? Yes. Remember, they can all be false. They could all be true. It could be true, false, false, true. It could be false, true, true, false, like it is here. But what it can't do is alternate. It can't be false, true, because of the ones that have to match. You with me? It's the ones that match, logically equivalent. So when we go on to look at a question like this, it says, the following statement is true. If the leading coefficient a sub n of a polynomial is 1, then any rational zeros of f of x are integer factors of the constant term a sub 0. Which statement must also be true? Now, do you even know what that's saying? No, I took that right out of what we're doing in pre-cal. It doesn't matter. It doesn't matter if you've learned it. It doesn't matter if it makes any sense at all to you. It could be, again, like about nuclear physics. I'm not asking you to read each one of these and analyze them and see what you know about integers and constant terms. None of that is relevant here. All I want to know, and it doesn't even say which of the following are true for sure. You know, how many of them are true. There may be more than one that's true. It says which of the following must be true, basically based on what we have, right? So if this is this statement a conditional statement? Yes, it is if then, right? So this is in the form of if P, then Q. So the P part is the leading coefficient of a sub n of a polynomial is 1. The Q part is any rational zeros of f of x are integer factors of the constant term a sub 0. So now we look at the structure of each one of these. Okay? So this says, if the leading coefficient of a sub n of the polynomial is not 1, okay, well, this right here is P, so that means this is not P, then any rational zeros of f of x are not integer factors, so that's not Q. You see how you match that up? What it actually means doesn't matter. Whether you know that this is true or false, I'm telling you it's true, so none of the rest matters. So then I look at the next one. If any rational zeros, okay, so the rational zeros part was the conclusion, of f of x are integer factors of the constant term, so that's not it's Q, but it's not negative, so it's just Q. Then the leading coefficient of the polynomial is 1. Well, that was my hypothesis, so that's P. Then I look at C. If any rational zeros, okay, so the rational zeros part was the Q part again, but it says are not integer factors, so that's not Q. Then the leading coefficient, which is the hypothesis part, is not 1, so that's not P. The last one starts with the leading coefficient. That's the P part. It says not, so it's negative. Then any rational zeros of f of x are integer factors, so that's the Q part. but it's true. Oops, so it looks something like that. Okay? Everybody understand how to get what I just did? It does not matter if you understand what the sentence means. It doesn't matter at all. Even if I didn't tell you if it was true or false, you could still tell me which version of these that is. Does that make sense to you? All right, so what I have here, this is the original conditional statement, right? If I do if not P, then not Q, which version is this? The inverse, okay? And then if I do if Q, then P, what's this? Converse. If I do if not Q, then not P, what's this? Contrapositive. And then what is this one? Nothing. It doesn't even make any sense, right? Ooh, not none. So it is, if I know that this one is true, what's my answer? Which one has to be true? C, because it's the contrapositive. I don't want you reading these and thinking, okay, leading coefficient, what does that even mean? It doesn't even matter right now. Doesn't matter at all. It's just how is it set up? So now this one has to be true. Is it possible that these could be true? It's possible. It's not asking you that. You don't necessarily know that without knowing the content. Okay, so there are times where you're going to be asked that when you're expected to know the material, if it's about geometry or whatever else. But if you're asked some question about anything, because you can sit there all day and second guess yourself and trying to reason through this, and it can get very confusing even if you don't think it can. It totally can. Look at the structure of the sentences, and that's all you're doing. Okay? We good? Yes, ma'am. Why does it have to be C? Because the logically equivalent statements have the same truth value. Conditional and contrapositive are always the same. Converse and inverse are always the same. Always, forever and ever. Amen. So if I told you that this, so what if I gave you this statement and I said the converse of this statement is true? If the converse of this statement is true, then which other statement has to be true? The inverse. Then my answer would be A. I just changed the question. Does that make sense? And I wouldn't even have to tell you if this is true or false because that wouldn't matter at that point either. You okay with that? Okay. So it's all about where you put your knots and how you write the sentence. Okay? Any questions at all? All right. So we're going to do a little activity, and then I'm going to give you your quizzes back, and we're going to talk about a few things. So if you haven't glued that in, go ahead and glue that in.